There are three essential things you need to know about to have a decent idea of how to use Docker. Understanding Docker Hub, running containers, and defining images. Before I go further, I want to be really clear about the difference between Docker images and Docker containers. So to recap, Docker images are a collection of all of the software that a particular application needs in order to run. They contain the operating system, the code environment, the dependencies, everything. Docker containers are instances of that software actually running. So from one image, I could make many containers which are all running the same software. Okay, so to get started, we need to install Docker. Just hit whichever one of these applies to your system and then step through the process. So the first of the essential things you need to know about is Docker Hub. Docker Hub is an online repository of Docker images. Check out all of these publicly available images on Docker Hub. You can see there are images for really any of the key components of any modern software system. So you can see, for example, here, Postgres, a SQL database, Ubuntu, Python, Redis, Node, MySQL, Golang, Nginx, Mongo, so many different typical components of modern software stack that have been defined as images. You can pull those off of the shelf from Docker Hub and start running them. And again, these images contain all of the dependencies required to create Docker containers which run that software and will run in the same way on whatever machine you put them on. So as an example, I'll set up a Postgres database by pulling the Postgres image from Docker Hub. So here you can see the official Postgres database image. Click into that. You can see the details of it down here. But the important thing is this command over here. I'm going to copy that command and I'm going to take it to my terminal in VS Code. I'll just paste that in, docker pull Postgres. If I run that, the Docker command line interface is going to go to Docker Hub and pull that image. You can see it downloading different parts of the image to my machine right now. So brace yourselves, because what this is going to allow me to do is to run Postgres with no setup, no installation, or any of the typical troubles which can come if you install it by itself. Instead, that container has everything already contained and set up, ready to go. All I need to do is to create a container from this image and run it. Warning, I'm going to use a long and complicated looking command here, but I'll come back and break it down in just a minute. So to run the Postgres container, I'm going to do this. So I hit enter, it gave me a long ID looking thing, and now I'm back at the command prompt. So what happened there? Well, I hope it's now running the container. So if I want to see that, I can use docker ps. And with that, I can see this table of different containers which are running. So the image which I just started running is called Postgres, created 20 seconds ago, and the name I gave it was my Postgres container. So that is it. That's running Postgres right now. I'll prove it to you by connecting through pgadmin. So there it is, I've connected to that Postgres database, which is running on my machine. And it took me 2 commands to set that up, docker pull and then docker run. And what's important to notice here is that this isn't because I've got some special setup and I've got everything pre-configured. This would work on any machine running any operating system as long as that machine has Docker. So essentially you can think of Docker as running its own computer, which is then running Postgres. And that Postgres image is probably built on top of the Ubuntu image. And so all of that is kind of acting as its own machine. And I've just kind of connected to it as I would if it were an actual computer elsewhere. But really, it's running virtually on top of my Mac OS operating system. Now let me go back to that command and break it down a bit. So I ran this command to run my container. So what I'm doing is using the docker CLI and the docker run subcommand, and then I'm giving it a bunch of different flags. So the first one is --name, my Postgres container, and we saw that this, as you guessed, is the name which is given to this Postgres container. Then I gave a -e flag, which is for an environment variable, and I passed in the environment variable Postgres password equal to my secret password. And this is something which is specific to the Postgres image, which expects there to be that environment variable configured. And that's why when I went into the pgadmin console to connect to that database, that was the password which I entered. It was the one which I'd specified here. Then I ran -d, which is for detach. That means it runs in the background, which is why as soon as I ran that command, I was returned to the prompt. It didn't leave me kind of shelled into the Docker container itself, as if I was shelled into another computer. Instead, it just returned me to my command prompt. Then I used the -p flag to do what's called port mapping. So I'm mapping port 5432 of my computer to port 5432 of the container. So remember, the container is much like another computer. And so I want to network them together. And so essentially I'm saying connect those 2 ports together. So the port just being the network interface on my computer, which can communicate with other pieces of software, in this case Docker. Other ports would be communicating with, I don't know, the internet or with your mail server or with whatever else. But this port mapping, it just connects. What does it do? How do I explain that? So I use the -p flag to do port mapping between port 5432 on my computer and port 5432 within the Docker container. So ports are just network interfaces that your computer can use to communicate with the internet or other containers or many different kind of things. So in this case, I'm specifying that the interface number 5432, whenever communication is sent to that, it should be mapped to the Docker container. So if I send messages to that port, it's going to send them to the Docker container. And that 5432 is the port which the Postgres container is by default set up to listen to requests from. So in this case, all that affects is the host, which I had to specify in my pgadmin to connect to the Postgres instance. It's basically saying, okay, well, what's the address of this computer? So my Docker container is essentially a virtual computer running within my own machine. That container has its own ports. And here I've mapped port 5432 on my local machine to port 5432 on the container, which is where Postgres is listening for connections. The --rm flag removes the container when it's stopped, instead of it keeping it lingering there dead. And finally, Postgres here is the name of the image which I want to create the container from. So I don't expect you to know all of that, so where did I figure it out? Of course, it's in the documentation. So let's check out the documentation for Docker run. So in here, you can find all of the details of how to use the run command. And as you scroll down, it'll go into detail of all of the different configurations you can set up. So here's, for example, the -d flag explained. So we've already seen that Docker Hub has loads of publicly available Docker images. We've seen how to run them in the command line, and now I want to show you how to create your own containers. So we define how to create a Docker image using a Docker file. Your Docker file might look something like this. It contains a sequence of commands which we call instructions. So this is a from instruction, a run instruction, copy instruction, and so on. The instructions define how to create the Docker image step by step. So each of these instructions perform some particular step. They're going to run in order, and at the end of that, you're going to have a Docker image containing all the software that needs to go and the instructions for what code to run when you create a container from that image. So here we've got a very simple Docker file that illustrates how a few important instructions work. So every Docker file starts with a from instruction. It specifies the base image which the image will be built on top of. So in this one, I'm going to end up using some Python. So I just started from the Python image. And here is where you specify the version. So you separate the name and the version with a colon, and latest will just get the latest version. So it's going to firstly look locally for a image called Python, and otherwise it's going to pull it from Docker Hub. This Python image, as you probably guessed, it has Python installed. And we're going to build on top of that. So you can build on top of other images, stacking layers together to create your own image. So if you need to run something which depends on PyTorch, you would build your container on top of the PyTorch container. The run instruction is for running terminal commands. So what this one's going to do is it's going to make a directory. And just like we looked up how to use the Docker command line, you can also look up how to use all of these instructions in the Docker file. So inside the Docker file reference, you'll see the details of how to use all of these things, and way more detail and way more accurately and clearly than I could possibly try to tell you. So make good use of this and practice getting used to how to read it. The workdir command sets the current working directory within the image for following commands to use, and the copy instruction copies files into the container from where the image is being built. Here, we're copying in the Python file into the working directory in the Docker container. So we've got two arguments here to this copy command. The left-hand side one is where on my machine am I copying things from? And this one, the second command here, the second argument here is where I'm copying things to within the container. So again, you want to think about it as two separate computers, and I'm copying from this location on my host computer, that's my Mac, which I'm running everything on right now, and this is the current working directory inside the container. So finally, we have the entry point instruction. Entry point is the shell command, which is going to run when we run a container from this image. So it allows you to configure the Docker container as an executable that executes this command immediately when the container gets run. Your container could immediately start hosting a database, training a machine learning model, serving an API, or whatever it is, depending on what you put in this entry point instruction. In our case, I've got a Python file. All it's going to do is run a loop for 100 seconds and log each index into a file. So I've got a Docker file, but I don't have the image yet. What I need to do now is to build the image from this set of instructions. So I'm going to go back to the command line, and I'm going to use a new Docker command, docker build. So Docker build is going to create the image from the Docker file. It only requires one argument, and that's what we call the build context. The build context is a set of files located at a particular path or URL. And those files are sent to the Docker daemon during the build so that it can use them to build the image. And that place where it builds the image is somewhere else on your computer deep in the Docker system files. So here I'm going to do docker build dot. So dot represents the current directory, and that means everything in the current directory is going to be in the build context, so it's sent to Docker, which can then use all of that stuff to build the image. But it's not just everything directly in this folder, it's everything recursively in this folder, which is sent to the build context. And again, just to be clear, this is just stuff that's used for building the image. It's not stuff which is put in the image. So the image doesn't contain everything in the context here. This is just a set of files which can be reached during the build. A lot of people confuse this argument with which folder they'll find the Docker file in, but that's not quite true. And the reason why people think that is because the default place that Docker expects to find the Docker file is directly within the build context, within a file called Dockerfile with a capital D and no extension. And that's exactly where mine is here. But this dot doesn't represent where the Docker file is, it represents what should I send to Docker so it can build the image. If you did want to specify a particular location for a file or use a file name different to Docker file with a capital D and no extension, then I think you can use the -f flag to specify wherever that is. And I'll leave you to look into it, but one other thing to note is that if you don't want things to be sent to the build context, for example, if you've got like a big file system in here and you don't want to copy all of that over, then you can specify that in a .docker ignore file, much like you can in GitHub's .gitignore file. The only other thing that I'm going to add to this command before I run it is a -t for tag, so I can tag it with a name. And now Docker's building it. If I want to see my images, I can use Docker images. And there I can see the image which I just created. One thing to be careful of is filling your computer's memory with Docker images. I remember running this command one time and finding something like 60 gigabytes worth of Docker images in here, so make sure you clear them up. So now that I've got the image, I can run a container based on that image. And the simplest way to do that would be to run docker run name of image. So I've screwed something up and my Python file is not working, so I'm going to change it just to simplify things. Keep it like that. So now because I've changed some of the files which are part of my image, I'm going to have to rebuild the image. And so that's fine, I'll just run the build command again. So docker build, tag with the same name, specify the build context. So I've run that, and now I'm going to run a container from that image. Great, well, something seems to be happening. I've not been returned to my prompt, and it's probably because this image is running. If I open up a new terminal now, and I want to see what containers are running, I can do docker ps for processes. And here is all my running containers. You can see that the names are created randomly. So we can stop the container by name by doing docker stop container name. And if you want to stop it instantly, you can do --time equals 0. So now it's killed that terminal running, it's killed that container. But it's pretty annoying to have to find the name inside this docker ps. So what we can do instead is name our containers using the --name flag. So if I were to run it again, I'd do --name. I'll just call it my container for now. Now, if I docker ps again, you can see my container's running. And now I don't have to look up the name. Instead, I can just do docker stop the name, which I know I called it. So now let's try and run it again. And now you can see I get this error. It says this name is already in use. But I can see if I run docker ps, it's not there anymore. So where is it? It's been stopped, but it hasn't been removed. So if I do docker ps-a, then I'll see all of my containers, whether they're stopped or not. And over here, you can see that there's this my container that's exited. So what I want to do is delete that exited container. So to remove that stopped container, I can do docker rm for remove, followed by the name of the container. And now if I list them again, the container's gone. And I should be able to run that container again with the same name. And it's running, so that looks good. But again, it's a bit cumbersome to keep having to delete the container like this. Instead, what I'd rather do is just remove it as soon as it stops. And so to do that, you can specify the --rm flag. And that's one I used earlier. So I'll need to remove the previous one firstly. And now, if I run this container, and then I stop it, and then I list my containers, again, it's gone. So that was removed when it stopped. And the final thing I'll show here is the detach command. So if I don't run it in detached, then I have to keep this terminal open whilst the Docker container's running. If I Control-C this terminal, then I kill the container. Instead, what I can do is I can just do -D, and that means it's going to detach the running container process from this terminal and instead run it in the background. So if I run that, I'm immediately returned to my command prompt. But if I list my running containers, then you can see that it's still running. So that's more than enough to get started with using Docker. You've seen all of the images available on Docker Hub, how to run containers and how to create containers, and the rest is up to you.